All right, welcome everybody to our spring Desert Skies virtual star party. This is the first time that we're actually streaming it live to YouTube. In the past, we've usually done it to Facebook, and we wanted to try going to YouTube this time. So we welcome everybody, and if you're on YouTube and watching, by all means, go ahead and chime in and with the chat and let us know where you're watching from. I would like to do a special welcome to the Esmond Station K through 8 folks here in students here in Tucson. Hopefully some of them have logged in and watched, but we invited them to participate in our virtual star party. So we have 3 telescopes that we're going to be sharing various objects as we go along. So to start with, I'm Jim Knoll, and I'm the Star Party manager for the Tucson Amateur Astronomy Association. We average probably about 20 to 30 star parties a month when we're at peak. And so we do a lot of in-person events, but we did want to keep doing the virtual star parties just so that we've got some good connection and be able to share our nice dark desert skies with the rest of the country and maybe even some people around the world. So we will be doing, after we're done with this one, our next one will be in November. So it'll be a little bit of a break. We pretty well kind of shut things down around here in the summertime because of our monsoon rains, which is hopefully ones that will be active and we'll be able to get some good rain, because here in the desert, we always get excited when it rains. All right, so with that in mind, Bernie, I'm going to turn it over to you first and let you show your first object.
And I forgot you muted me. Sorry about that. Do you hear me now?
Yeah, we got you.
Okay, very good. My name is Bernie Stenger. I'm one of the astronomers tonight, and I'll be sharing a number of objects with you. Right now, Jim's indoors where he can be nice and comfy. We're outdoors in a nice Arizona evening. It's actually quite pleasant out, but a little bit breezy. So if you hear kind of gusts of wind every now and then, you'll understand. I'm using tonight a scope called an EV scope, or enhanced vision scope. It's made by Unistellar. It's a French firm. And I've been using it at star parties now very successfully. And I'm going to give it a shot tonight on our virtual star party as well. So with that, I'm going to move to the first object. And let me see if I can bring that up for you. Okay, what you're looking at now is an open star cluster. This is in particular called M46. The M refers to Charles Messier. It's number 46 on the Messier object list. Messier was an astronomer back in the late 1700s that looked for comets, but he also cataloged a number of objects out in the sky that weren't comets, but he noted them and put them on his list. So this is number 46 on the Messier list. This particular open star cluster is in the constellation of Puppis. And there's about 500 stars that are associated with this star cluster. Now, what is a star cluster? A star cluster, an open star cluster like this, is a cluster of stars that are all approximately the same age and were born from the gas of a large molecular cloud. Now, that molecular cloud was a big cloud of hydrogen. And these stars slowly formed from that cloud of hydrogen over millions and millions of years. Now, you don't see the cloud anymore because the stars, once they existed, used their solar wind to blow the cloud away. So what's left is just the collection of stars. Most of these stars are in the range of 250 million years old. Now, that might seem like extremely old stars, but actually, in the realm of stars, the age of stars, those are very young stars. As an example, our sun is 5 billion years old, or 5,000 million years old. So 250 million years old is almost brand new. This particular star cluster is 4,900 light years from Earth. So the light that we're seeing right now started out from these stars 4,900 years ago. Most of these stars are loosely bound by gravity. The stars kind of hold each other in place. So over time, the stars will slowly migrate out and eventually disperse enough that they won't look like a cluster any longer. But that takes millions and millions, possibly even billions of years. For those of you who have looked up in the sky and seen clusters of stars, the Pleiades is an excellent example of a star cluster. That particular cluster is closer to us than this one. So that's why it looks more condensed than this one does. Now, also within this field, if I zoom in, I'm going to zoom in a little bit, you'll notice there's kind of an odd looking little ring there within the star cluster. That's called a Planetary Nebula. That star with the ring around it actually exploded thousands of years ago. And what you're seeing is the remnants or the shell of gas that star blew off. And it's slowly radiating out into space as a ring. Looks a little like a smoke ring. And over time, that ring will get further and further away. It will get larger, but it will slowly dissipate until it's no longer visible. But that'll take many, many, many years. That particular planetary is actually not within the star cluster. That planetary is 3,000 light years closer to us than the star cluster is. So actually that planetary is not within that star cluster at all, but it kind of looks like it is simply because it's in the same field of view. So with that, I'm going to pass it over to anyone else who might have a comment in the group.
Yeah, that's a good looking picture, Bernie. As Bernie was saying, the open clusters like this are some of the younger stars in our galaxy. And so, most stars are born, when they're born out of the same nebula, become part of an open cluster, and they'll travel around the Milky Way galaxy together as a little family unit. And eventually, they're held together by gravity. So eventually the outer stars and kind of drift away, and then the next layer and the next layer. And so it's kind of like, as families age and they move to other parts of the country or the world, and they hopefully come back together later on. But yeah, this is a really good one. And it's kind of cool to be able to see the Planetary Nebula in the middle of it, to see, what it's going to be like when our sun gets towards the end of its life. All right, Rick, you ready?
Yes, I am.
Okay, I'll stop sharing here. Maybe. Hold on a minute.
I gotcha.
Can you do it for me? Thank you.
Hi, everybody. Rick here. I've got a new scope this week, and it's going to give very wide-angle views of things for you tonight. A little bit different than what we've shown in the past. So, Jim, you can see my screen?
Yes.
Okay. So what we've got here is a very vast expanse of space up in the Orion constellation, which is getting late in the year for Orion. Orion is starting to set on us this year. It's almost gone for the year. But in the lower right-hand corner here, you have the Orion Nebula. There's a very large cloud of mostly hydrogen gas. That red you see in there is the telltale sign of ionized hydrogen there. And this cloud is forming stars. There's that bright core right there that's all white. It's that way because there's little baby stars in there being born, and they're putting out a lot of energy. And so that's why that's so bright in there. But then if you go to the upper left here, we have another treat. It's a little fainter because it's hard to balance exposures between something really, really bright and something really, really dim. But right in here next to this very bright star is what's called the Flame Nebula. And this bright star is the leftmost star in Orion's belt, on the tack. So that's a guidepost for you where this is, up there in the left star of Orion's belt. And then you can see some red glow going across here. And it's very, very faint. It's kind of small, but right there is the famous Horsehead Nebula sticking up, that little black part right there. This whole region is actually filled with nebulous gas all through here. Longer exposures over a longer period of time would expose it. You'd actually see pretty clouds in between these two all the way across. And this whole area is called the Orion Molecular Cloud because of all the gases up here. The Orion constellation itself is about 150 light years across, and it's about 1,400 light years away from us, which is relatively close. It's heavily studied by scientists because it's the closest star forming region to us. So it's very easy for them to see. Something I encourage everyone to do when Orion is up in the sky, if you own a pair of binoculars, go up and look for the Orion Nebula. It's very easy to find. And so if that's 150 light years across, you can kind of guess the math, the distance between these two. You're probably looking at a span of 800 or 900 light years going across there. That's all, Jim, unless somebody wants to add anything else.
No, that's a great view of both the nebula and the flame and the Horsehead and everything. So yeah, so when Bernie was showing earlier the open cluster, so that's the second layer or level for new stars. They start off in a nebula like the Orion Nebula, which is just a huge cold hydrogen gas cloud. And once that nebula is all used up and all those stars are born, then they will become an open cluster, and we'll be able to look at all the stars in there. Right now, the four main stars in what we call the trapezium are kind of lighting up the nebula, and so that's what's allowing us to see the gas in the nebula. All right, excellent. Jim O'Connor, you ready, or do we want to come back to you?
I think I can give it a shot.
Okay, it's all yours.
Okay. If I can make the magic work. Coming through yet?
Got it.
Got it? Okay, I do have to shift my view to a script and talk about this object we're looking at. That fuzzy area on the left hand part of the screen is called a supernova remnant. That means that's what's left over when a star at least 8 times as big as the sun has reached the end of its life, when it's done burning up the hydrogen and goes through other elements, and it finally reaches to silicon and sulfur. And when it gets enough heat in there from the gravity collapsing the star because it doesn't have enough energy, and starts creating iron, and that iron is actually steals energy from all the other nuclear reactions going on in the star. And 10 seconds after the first iron molecule is made inside that formerly giant star, it causes a nuclear conflagration. It just really, in the inside, there's a tremendous nuclear burst. And the outside, they're still all rushing in because of gravity. So that's how you make all the elements that we have in the universe. All the elements heavier than iron are made right at that moment. So if you look down at your feet and you're standing on some kind of rock or sand or a city street, that's silicon in the rocky material that's in concrete or in the dirt underneath you. That came from the end of life of a star at least 8 times as big as the sun. This item itself, when it went through the supernova, the debris that was left behind was about was a ball about 19 miles wide, and it was spinning, and it still had the magnetic field from the parent star with it, but now it was compressed into a ball 19 miles wide, and so that caused a lot of magnetic and radiation gamma effects, and it would send out pulses looked like a lighthouse when these poles were moving by. So that became known as a pulsar, and that's a supernova remnant that's spinning out there. The actual cloud you're seeing there is 5.5 light years across. It's in the constellation Taurus, and it's just starting to set. It's getting close to setting. That's another reason why it's kind of fuzzy. Plus, I got some clouds around my house and near that area. It was first observed by an astronomer named William Parsons in 1840 using a 36-inch telescope. And he produced a drawing that looked like a crab. But we know the exact day that our view of that exploding star happened. It was July the 4th, 1054. And the reason we know that is the Chinese were excellent observers and astronomers and watched the night sky for what they used to call visiting stars. And they actually logged it. And it was found when the Four Corners area around the upper north corner of Arizona, the 4 states that have a corner up there, the Native American cultures that were in there, the early Chaco Canyon and some of the other canyons, White Canyon, Navajo Canyon, their residents actually sketched what they saw. And not only did they see it at night, but it was bright enough that in the Chaco Canyon area, it was visible in the daytime as a bright star for 23 days. So that's a rather interesting little object out there. It's only 19 miles across for what's causing that thing to glow, 5.5 light years across to make the gas that it blew away actually act like a neon sign for you. And that's about all I can say about it. Oh, it's 6,500 light years away, in case you're measuring. A light year is about 6 trillion miles. So that's quite a ways away. You really have to take off your shoes to count that one for how far away it is.
Yeah, so I wonder, what they were thinking back in 1054 when they saw that, and if they really knew what they were seeing, or just a new star to them in the daytime sky.
For the Native Americans who would have seen it, they would have thought that it was a gift from their creator or from nature. It was a spirit they had with their creator. So nature was what they were always paying attention to. And so they thought it was a gift, and it was up to them to figure out what it meant. And so they would have a lot of tribal councils and would sit around and think about it. They thought it important enough to paint on the cave walls or the building walls in many of the canyons in northern Arizona.
Very nice. All right. Thanks, Jim. Okay, Bernie, you ready for number 2?
Okay, sorry about that. You had muted me and I wasn't aware of it. All right. So am I ready for number 2? I'm not sure I want to go there, but well,
Okay.
we'll try my next object here. What I'm going to look at next is a different kind of star cluster. Looked at earlier was an open cluster. So this time I'm going to look at what's called a globular cluster. Let's see if we can bring that up for you. All right. Okay, what you're seeing right now is a globular cluster, or what we use the highly technical term of a glob. And I'm sure that's where they came up with the name globular cluster. This particular cluster is called M3. So this would be number 3 on the Messier list that I referred to earlier. Globular clusters, and I'm going to start zooming in on it so you can see it a little more clearly. Globular clusters are different from open clusters in that the stars are in a much tighter configuration. In the case of M3, which we're looking at now, there are over 500,000 stars in this tight knot of the star cluster. And as you can tell, the center is so condensed with stars that they just overexpose the image, and you can't specifically see any individual stars. But around the outside of it, you can certainly see how it's very concentrated in that area with stars. This particular cluster is 33,900 light years from Earth, or almost 3,400 light years away. So much further than the open cluster that I showed you earlier. These globular clusters tend to hover around the center of our galaxy, the Milky Way galaxy. You can kind of think of them like bees around a beehive. And they've found so far about 150 of these around our Milky Way galaxies, towards the center of our Milky Way galaxy. I'm going to zoom down just a little bit so you can make it out, the further extents of it. This one is about 8 billion years old. So very, very, very old objects. Certainly a lot older than the 250 million year old open cluster that I showed you earlier. Some of these globulars are so old that they're close to, if not the same age as the Milky Way itself. This particular cluster is in Canes Venatici, in case you were wondering what constellation it's in. It has over 274 known variable stars within it. So it's not only a favorite for amateurs to look at, but professionals as well, because looking at variable stars and researching variable stars gives a better understanding of the evolution of stars and how their lifetimes evolve, and in particular towards the end of their lifetimes when they tend to be more sporadic and variable. So to have 274 variable stars all in one area makes it very handy to monitor a bunch of them at the same time. The diameter here of this globular is about 180 light years across. So a very, very tight combination of stars by far. One of the things I like to consider is what it would be like to live on a planet rotating around one of these stars. Can you imagine what it would be like with all these stars so close by? I suspect that it's never nighttime. There are probably multiple suns in your sky at any given time. In fact, it's probably not very not very attributable to life there. It not having nighttime, it would certainly require a completely different type of life to deal with that amount of light and that amount of heat and energy on a continual basis. Anyone else have any comments?
Yeah, so as Bernie mentioned, there's over 500,000 stars in that little cluster. So if you think about it, the nearest star to our sun in our solar system is Proxima Centauri, and that's 4.2, so just over 4 light years away from us. Probably in that cluster, the average distance between stars is maybe 0.1 or 0.2 light years apart. So as Bernie mentioned, there would be lots and lots of stars in that night sky. So it would cast quite the glow upon the ground. Bernie also said it was about 33,000 light years away. And we are about 26,000 light years from the center of our Milky Way galaxy out on one side. This particular globular cluster is a little bit beyond the core from us. So it's just a little bit on the other side of the center of the galaxy from us. So it's a ways away. It's not on our side of the galaxy by any means. And as Bernie mentioned, that they're so tightly packed in the center that all you can see is just a glow of light.
Yeah, it's interesting that it's hard for us from our vantage point to see things on the other side of the galaxy because of the brightness of the center of the galaxy. But because these are above and below the plane of the Milky Way, they're more easily discernible from that distance. Okay,
Yeah.
I'm going to stop sharing and I'll let you move on to the next person.
Okay, we're going to go over to Rick.
Yep, I'm
And
ready.
all right, you're up next. Jim's having a little bit problems with his telescope, so we'll just bounce back and forth between Bernie and Rick in the short term until Jim gets going again. So over to you, Rick.
Okay, now we've got two objects in frame here, and they're a little bit on the dim side, but they are dim. These can't be seen with an optical telescope, not very easily. The first one up here in the upper right, you can see a reddish glow, and you'll see an indent here, and then it comes back around. Well, this is known as the Heart Nebula, and it makes a nice little heart shape here. In the center of it is a very young star cluster, only about 1.5 million years old, which is very new for a star cluster. And so they're burning very, very hot, and they're what's driving all the energy in this nebula here, driving all that out. And this is part of it too back here in the far upper right. So this is the Heart Nebula. And we go over here to the lower left, you see another grouping of nebulosity. Well, whimsically enough, that got named the Soul Nebula. So here you have in frame the Heart and Soul nebulas. These are in the constellation Cassiopeia, which is near our northern part of our sky. So these two objects never rise or never set. They're always in our sky. They may be low on the horizon, but they're always visible as they rotate around the North Star. They're about 6,000 light years away. So further than much further than Orion was, and that gives you an idea of their size. These things are really, really big. Let's see, anything else here? That's about all I got. You got anything to add, Jim?
No, those you can certainly see how faint they are, and that's with a camera. So trying to see these visually, it would take a really good-sized telescope to be able to see the shades of gray.
Yeah,
You'll notice in most of the images that the cameras are picking up color, whereas if you were to look through the telescope and through an eyepiece at a lot of these objects, we would say just shades of gray. And so that's because most objects are so small and so dim and far away that some of our eyes just can't pick them up, or the edges of the eyes, the rods is what we use primarily for seeing at night. And so that's why you'll always pick things up, movement out of the corner of your eye at night, more so than you do right in the center. And the same is true when you're looking through a telescope. And that's why it's important. If you ever go to a star party in person, one of the things we frequently say is, you don't want to be looking at your phone. You don't want to have any bright white light going, because it takes your eyes about 20 minutes to really get dark adapted. And so, if you're not dark adapted, then you're going to really struggle to see stuff in the eyepiece. And so it's really important. And just one little quick white light, and your dark adaptation is gone, and you've got to start the process all over again. So that's why you'll see most astronomers using dimmer red lights to protect that night vision when we're looking at charts.
Yep, I'm looking at a computer screen right now, and I look straight up, and I don't see any stars. I'm also going to mention again, the red appearance of these nebulas is the telltale sign that these are giant hydrogen gases. There's probably also traces of oxygen and sulfur in there too. All three usually accompany these nebulas.
Yeah, very nice. All right, Bernie, you ready for the next one?
Yep, sure am. Hold on a second here. Okay, here we go. All right. So what I've shown you so far, open cluster and globular cluster, we're talking about objects that are in or nearby our own Milky Way galaxy. So we've been in the range of 10,000 to 50,000 light years away. Now I'm going to shift to something far more distant. This is a galaxy, another galaxy far, far away, as I like to put it. This particular galaxy has the nickname of the Needle Galaxy. And it's quite obvious why it has that name. It's very long, elongated, and very, very narrow. So I'm going to zoom in a little bit so you can see that a little better. There, that's probably a little more clear. What we're looking at is a galaxy on its edge. So I'm sure you've heard how the Milky Way is described as a plate, and the center of the plate has a bunch of stars, and then you've got spiraling arms that make up the rest of the plate, if you will. But if you look at the plate edgewise, well, now it's long and narrow. And that's exactly what we're looking at here. This is an edge-on galaxy. So we were able to fly to the upper right corner or the lower left corner and then look over at the galaxy, you'd see a great big spiral galaxy with the plate facing you. But from our vantage point on the Earth, what we see is it edge on. Now, if you look very closely, right in the center, you can see there's a very bright central core. And that's where, probably 40 to 50% of the millions and millions of stars or billions of stars are located. But the other 50% or so is also out on the spiraling arms themselves. And that's why you see the bar going to the upper left and lower right. Also, you'll notice there's a kind of a dark band that cuts right through it. And that's at the very edge of the galaxy, there's probably a gas and dust and rocks and boulders and all kinds of stuff that are out on the very edge of the galaxy, and it's blocking the light and splitting it into a lower and an upper section. This particular galaxy goes also by the name of NGC 4565. That stands for the New General Catalog. It's a catalog of galaxies that was developed in the 1800s. This galaxy is in the constellation Coma Veronesis. And it's about 40 million light years from Earth. So the light that you're seeing from that galaxy started out 40 million years ago. And you're just seeing it now. By the way, I don't know if Jim or Rick or I mentioned, but the images that you are seeing tonight are live directly off of our telescope. So in between, when I pass it on to Rick or Jim, during that time that they're talking, I'm moving my telescope over to the next object so that we can look at it. This galaxy has a diameter, in other words, from the tip of the very upper left tip to the very lower right tip of 140,000 light years. That's a little bit bigger than the Milky Way galaxy. The Milky Way galaxy is probably in the 100 to 120,000 light years. And as Jim pointed out earlier, Earth and our sun are about 2/3 of the way out from the center of the Milky Way galaxy. This galaxy supposedly has around 1 trillion stars. Now, nobody sits down and counts them all, obviously. That would be an impossible task. But based on the amount of light and the amount of the size estimate, it's going to require that kind of numbers of stars to get this kind of brightness over that distance. This was first discovered by a famous astronomer called William Herschel back in 1785. And it's not on the Messier list. Charles Messier did not spot this. He never saw it. As to our knowledge, he never spotted it because it was probably too dim for him to see in his telescope. You'll also notice to the upper right, there's a line of stars, 5 stars kind of in a row. And right at the end of the 5 stars, there's a little fuzzy patch. And that is another galaxy. It's a dwarf galaxy. It's probably a companion of the Needle Galaxy. And it goes by the name of NGC 4562. It's not uncommon to see other galaxies nearby. It's typical because galaxies travel through space in groups. And this is probably one of the group galaxies along with the Needle Galaxy. Any other comments?
No, that's an awesome view of a more or less edge-on galaxy. As Bernie was mentioning, galaxies are kind of like plates or CDs. They're especially the spiral galaxies. They're pretty spread out, but they're not very thick. In the case of the Milky Way galaxy, we're about 100 to 120,000 light years across, but we're only about 1,000 light years thick. So the orbital motion of everything going around the galaxy and that you're seeing in this photo keeps everything fairly flat. You can see right in the center where the core is, you can see a little bit of a bulge up above and below. And so that's a good indication that there's a lot of star material right in the center of that galaxy. I would guess probably, a quarter to a third of the stars in any one galaxy are probably in the core or near the core. We're fortunate here in the Milky Way where we live that we're out in the suburbs. And so it's pretty quiet. Not a lot of action going on, and it's a great place to raise a family of planets. So it worked out quite well.
Jim?
Anything else, Bernie? Yeah, Jim.
What I wanted to say was there was a person who started off as a good amateur astronomer and really popularized bringing astronomy to all people, and that was John Dobson. And for the time he did this, for almost 40 years, I think, John Dobson had his own stories he would tell about these areas. Now, the constellation Coma Veronesis is the Greek translation of Coma meant hair. That's why a comet was a hairy star. But the way Coma Berenices got named is there's a cluster of stars in there that looks like a lot of hair that was placed up in the sky. And so there's a legend about Queen Berenice in Egypt, and it just involved her sacrificing her hair to the oracles if her husband came home from a battle uninjured, and she did. So she gave her hair away, and Zeus put it up in the sky to remind us to sacrifice for each other. So Coma Berenices means the hair of Queen Berenice. Well, that object you're looking at right now, John Dobson named for himself as Berenice's hair clip because of the long, skinny shape. He's the only one who used to use that, but he used to always insist that whenever he was around and you showed it to anybody, you had to call it Berenice's hair clip.
Very appropriate.
Good
Yes,
story.
indeed. Yeah. All right, Rick, you're up.
Okay, give me a second here. Let's see. Share. Go. So what we have here is another dim region. I promise the next one's going to be much, much brighter than this. But this is called the Seagull Nebula. And up here you can see his head, and then his wings are stretching out on overside all the way down to here. Again, a very large region of nebulosity. You know, if the full moon was in this picture, it would only be a relatively small circle here. That shows you how large these structures are up in our sky. They're very, very large. We just can't see them with our eyes because they're so dim. So this has been known as the Seagull Nebula since it was first seen. It just popped out to people as that of an outstretched bird. It's located between the constellations of Monoceros and Canis Major. It's about, again, it's in that 6,000 light years away area. There's several open star clusters in this. You can see one down here. There's one over here. There's another one up here. And some of those star clusters are, again, providing the input to the light that's lighting this up.
Yeah, I like the nebulas like that. You know, a lot of them, like the Heart and Soul and the Seagull here, are they actually kind of look like what they're described as.
Yeah.
If you can see enough of them, you know, with the camera you can see enough of it. Visually, sometimes you can't, but with the camera you can.
Yeah, some of the nebulas don't look like what they're called, but I've tried to pick some that actually do look like what they're called. Yeah, so this is a fun one to look at.
And are most of those stars look like they're probably between us and the nebula?
Some of them are clusters in the nebula.
Looks like there's a bright spot right at his bottom wing that is an extra. Yeah, right there is kind of an active region, I guess.
Yeah, that is. Let's see. I got some notes here.
I would guess that if
that's the star.
were
It's a B1 class star, and it has a number after it. But yeah, it's not named.
I wonder if you were to zoom in on that, if there would be, you know, several stars that are lighting that up, or if it is just the one. It's kind of hard to. Sounds like it's numbered just as one. Yeah, it looks like it's just a very bright and big star.
Yeah. Let me get back over. I'll zoom in on the head too. The head's kind of interesting because you can almost kind of see like there's a mouth there. There's his beak coming out there, and there's kind of his mouth opening his beak. And then
It looks like a kind of looks like a Klingon warbird too.
yeah, yeah, it does. It does. It reminded me of that too when I first saw this.
That's the nice thing with astronomy is, you know, these objects and the constellations, they can be whatever you want them to be. You know, a lot of times we just go out in our backyard and you know, look around and point things out and say, well, what do you think that looks like? What does that
Well,
look like?
it's also, this isn't one that has that case, but it's interesting how some of the lesser known nebulas, their names have changed over time, and some have gotten updated more along the lines of popular culture. For instance, there's Thor's helmet, which actually does look like Thor's helmet, but it used to be called the Duck Nebula. And there's another nebula up there, not visible this time of year, called the Wizard Nebula, named after Harry Potter. But Golden Snitch and some other ones like that that have been renamed recently. So it's interesting how the names evolve over time. And
Yeah, very nice. I guess we got Bernie back. I think we lost you there for a little bit, Bernie, but looks like you're back.
Yes. Sorry about that.
That's all right. So if you're ready, you can we can go to your object.
I'm in the process of getting there yet.
Okay, all right, that's fine. While Bernie's doing that, let me just I'm just gonna
Maybe you could
share.
talk about how's Jim doing?
His mount is dead, so it's going to be back and forth between you and Rick. So what I'm showing here is a planetarium program called Stellarium. It's actually free. You can go to stellarium.org and download it for your PC or your Mac. And it's kind of a cool program because you can see the constellations, you can get information about them, you can do all kinds of cool things. So as you can see, I had it on the Seagull Nebula that Rick was showing. So up here in the upper left, it gives you some information about how bright it is and where it's at in the night sky. When it rises, when it transits, which is when it's the highest in the sky, and then when it sets, how far away it is, and a little bit description on it. So if you get an opportunity and want to download this, just go to stellarium.org. It's a really cool one. So here, like Rick was saying, it's this particular object is in between Canis Major and Monoceros. And here, if you zoom in, then it actually transitions to a picture that was taken probably by Hubble, or I'm not sure what pictures they used, but it shows the picture of the object that you're looking at. So it's a good way to augment your telescope if you've got one, or just to go when you're going out with your eyeballs to see what you got. So also in the night sky, and Bernie, just let me know when you're ready and I'll stop talking.
I am.
Okay. Let me just tell real quick, also in the night sky, if you look up and a little bit to the west is Gemini, the twins. So there's Castor and Pollux, and if you kind of follow them down, you'll see little line figures of the two twins and their feet like that. And Castor is a really cool star to be able to look at through a telescope because it's a double star system. So you can see two stars very close together. All right, I'm going to stop sharing. We're going to move on to Bernie.
Very good. All right, let me see if I can get things going here again. Sorry. There we go.
Yeah, you'll notice as Bernie's starting his shares that each scope works a little bit different and has a little different nuances to get the share going.
Yeah, got to get screens out of the way. All right, there we go. All right. My next object is something completely different. So I've been trying to show different types of objects this evening, and up in the constellation Virgo, which is where I've got my scope aimed up right now, is a very famous object, and I'll explain it in a little more detail here. Now, you wouldn't, looking at the screen right now, you'd think, okay, I've just got a bunch of stars on the screen, and you're right. Everything that you see, all those points of light that you see on this screen right now, are stars in our Milky Way of various distances, except for one. One of those dots is not a star. And can you guess which one it is? Well, it's pretty tough to do. So I'm going to have to help you there. If I zoom in on the very center area, you'll see 3 stars right dead center in kind of a little triangle pattern. Yeah, I guess for all practical purposes, you got a triangle there. The left star, in other words, the one towards the bottom on the left side, and just next to it, there's a little tiny faint star as well. But I'm talking about the left star of the 3. That is not a star. That is a quasar. Now, what is a quasar? A quasar is something that was discovered relatively recently, and it was finally figured out in the year 1963. So only about 60 years ago was they finally figured out what these things were. But that is not a star. That's a quasar. And the reason why they had trouble with identifying it was that back in the 1800s and the 1900s, astronomers were looking at the stars and trying to figure out what type of star it was, and they would do that by looking at the light spectrum of that star. And stars have what's called emission lines. They are bright lines in the spectrum, the visible light spectrum, that identify what type of star it is, whether it's a red giant or a blue giant or normal sequence star, or what type of material that star is burning at that particular time, whether it's hydrogen or helium or whatever. So astronomers were looking at stars and looking at the spectral lines of those stars, and they got around to that left star in that little triangle, and it had no discernible emission lines. It was just a big mess of lines, and it made no sense whatsoever. And it became what was called a real mystery as to what kind of star could possibly do that. Well, it wasn't until 1963 that a couple of astronomers studied it very, very carefully, and noticed that it not only gave off light, it was very strong in the radio spectrum. In other words, if you have aim a radio antenna and at that star, you'd pick up a lot of noise from it. And based on all their observations, they came to the conclusion that this star wasn't tens of thousands of light years. It wasn't millions of light years. It was actually billions of light years away. And therefore, it couldn't be a star at all, because we couldn't possibly see a star billions of light years away. And this particular quasar is 2.4 billion light years away. And that's about 1/5 of the age of the universe. That's how far away this light is. So the light that you're seeing from this quasar actually started out 2.5 billion years ago. And that's, if you know about the Earth was developed or created at 4.5 billion years ago. So this light is over half the age of the Earth, that light that you're seeing right now. Now, what is a quasar? Well, it took a lot of study over the years for them to finally figure it out. And it also helped to have the Hubble Space Telescope to take some images of it. But it turns out to be a very, very young galaxy, a galaxy that was formed early in the in time after the Big Bang, and that galaxy has a supermassive black hole in the center of it, and it's gobbling up stars like crazy, and it's sucking up stars so fast, and all these stars are falling into this huge supermassive black hole that the energy, the infalling energy from all of these stars is radiating out into space, and we see it as a point of light because of its tremendous distance. The amount of light that this this quasar is giving off to be seen as bright as it is in our telescope means that it has to be 4 trillion times brighter than our sun. It's an unbelievably bright object, and that's why we can see it so far away. Any other comments?
No, that's awesome. It's it doesn't look at like anything too special when you're just looking at it, but the fact that you're looking at something that's 2.5 billion light years away is just astounding that we can see. We feel lucky when we can look at galaxies and telescopes that are 60, 70, 80 million light years away. This guy is 2.5 billion. So yeah, and like Bernie said, it's halfway back to the age of the solar system. So.
Over halfway. Yeah.
Yeah.
It is really, really old light, as a friend of mine likes to call it. He jokingly tells me I go out at night and look at old light.
Yeah. All right. Great. All right, Rick, over to you. Unless Jim O'Connor, you got anything to add on anything, just chime in.
Not right now. I'm only about a few weeks older than that quasar.
Okay, I got a good one now for everybody here. Okay, what we're looking at here is known as the Rosette Nebula. And all this nebulosity here kind of gives it the appearance of a rose. And you see a hole in the middle here with stars in the center there. That is a star cluster. That was discovered first in 1690. The telescopes at the time were not powerful enough to be able to see the nebulosity there. The structure you're looking at here is 5 times the size of a full moon in our sky. So the full moon would be about the size of that center obstruction, is one way to look at it. And that is how large this thing is in our sky. It's again in that region of about 5,500 light years away. And it's big. If you think back, the first image I showed you with Orion, or the Orion Nebula, and how relatively small that looked on the screen, and that was 150 light years across, and it's only 1,500 light years away. Well, this thing is much bigger on the screen, and it's 4 or 5 times further away than Orion is, because you imagine the size of this structure. Again, it's a big cloud of hydrogen gas, and the reason for the central hole is those stars in the middle are a star cluster, and they formed in this cloud, and they are throwing off a lot of radiation, a lot of solar wind, and that pushed out this nebulosity. So that's what created that hole in the middle, to create that donut shape. This is really a spectacular object. If I could spend more time here taking more images, longer images, and integrating more, it would even look even better. But
Yeah, that's a fantastic image. I always like looking at the Rosette Nebula and the intricacies of the darker
there's
clouds, and
it's one you can keep coming back to, and because there's so much data to pull out of it, and beauty in it.
Well, and it's kind of cool to be able to see the open cluster evolving in the center. That'll eventually, as the nebula gets all used up, just like when we were looking at the Orion Nebula, then the Rosette will be no more, and it'll be an open cluster. Very cool. All right, Bernie, you ready for another one?
No, not. Sorry. Not yet.
Okay,
I can.
that's fine.
I can do one of two things. I could either show my setup and what's going on in the background here, or I can show another image.
Well, why don't you do that? Why don't you show the setup and what's going on in the background, and maybe the scope slewing over to the next image.
Okay. I'm going to stop sharing and then switch screens. So what you see here is my main computer, and it's running a piece of software known as Sequence Generator Pro. You can see the objects here we've already looked at: the Orion Nebula, the Heart and Soul, the Seagull, and the Rosette. It's now running on an object called the Flaming Star, which we'll look at next. It's running these exposures, and it just finished one. It's downloading it. So it finished, we're gonna get something interesting here. That was image 5 of 5. So now the telescope is actually moving to the next target after this. And you can see the little message down at the bottom there, but that's what it's doing. It's moving the telescope. You might even be able to hear it there in the background moving. And when it gets there, it's going to take a quick picture to make sure it is where it thinks it is. And the computer will make minor adjustments. If if it needs to get the object lined up in the center like we want it to be. So now it's done that. Should take a picture now. Now it's going to do the centering.
No, we're not actually able to see your picture. We're just seeing the screen in front of it. Right.
Yeah. Well, that's the previous one. That's just an alignment picture. That's why you only see stars. Here it goes. Here it's doing this screen here is showing that it's doing the centering the scope on the image. So it's taking a reference image here. And it did one, and it's validating the position. And if it's right on the money, it'll be good and it'll start imaging. If it thinks it needs to tweak it, it'll move the scope again. And no, it did make a slight adjustment. And I can control how close I want it and things. This is getting it within a pretty close approximation with tens of pixels of accuracy of what I want. And it did it. It's done. And now it's off to the races. Going to start imaging the next target. So Bernie, are you ready?
I'm in the process. Yes, I could probably take over.
Okay.
I'm also ready now.
Oh, let's let
Oh,
Mr.
yeah.
O'Connor have the stage.
Yeah,
Don't
let's
ask
let
me
Jim
how it did it,
go.
but
Go for it, Jim.
okay. And let me get my script up here. I almost started taking everything down. Okay, the object you're looking at, we've seen a couple of
Jim,
others
you need
so
to
far.
share your screen. You need to share
Oh.
your screen.
Well, the object I'm looking at, let me try this. High tech, you gotta love it.
Everybody has to realize we're dealing with a lot of technology here, all trying to work together. So
Yeah, I get confused and I realize I have to click 2 times to get it to share. It should be coming through.
Yes.
Okay, well, we've been talking tonight a couple of times about an object called an open cluster. And what you're seeing in the middle there is a kind of a peculiar open cluster because it's only got 50 stars. Its fancy name is NGC, the New General Catalog by John Dreyer in the late 1800s, who put together the Herschel family's observations into a single catalog. And this is New General Catalog 2169. That's not as romantic though as the name of it, the 37 cluster, because the stars seem to put the number 37 on the screen. It's sort of near the center up in the screen. There's only 50 stars in this object, and William Herschel actually discovered it on October 15th, 1784. This is a little closer than some of the objects we've been talking about. This is about 3,600 light years away from Earth. And it's only 7 light years across, which is rather small for an open cluster. And while we're talking open clusters, the largest open cluster you can see with your naked eye from the surface of the Earth is the Big Dipper. The inner 5 stars, not the very end star on the tail or the very farthest out star on the bowl, those two are just in the way of looking at the cluster. Those are called field stars, but it makes a nice picture. But those middle 5 stars are called the Ursa Major Moving Cluster. About 62 light years away, depending on the reference you look at. The stars have been extensively studied, and their spectra all show they were made about the same time out of the same mix of gases. And their proper motion, that means their natural motion across time while they move through space, is identical. So that is the indication that they were formed as part of an open cluster. So if you want to see an open cluster, since the Pleiades have already set, you can go out and look at the Big Dipper for the whole time that we've got the Big Dipper in this season for it. But this is the 37 cluster.
And this is one that actually looks like its name.
And I like to point out to people when I show this, a lot of us may remember the show Hitchhiker's Guide to the Galaxy. And in one of the episodes, they ask this computer, what is the ultimate, what is the meaning of life? That's what it was. What's the meaning of life? And the computer thinks on it for, I forgot how long a period of time, centuries, and finally comes up with the answer 42. And I like to point out that that can't be right, because nature has put 37 up there. So I think it's 37 myself.
The computer's wrong.
That's why it's called a confuser.
That's right. All right, Bernie, you ready?
Yes.
Okay, you got it.
All right. So back to screen share. And we're back on it again. This one here, and there we go. So my next object is another galaxy. This is called M101. Again, this is one of the Messier objects. This is number 101 on the Messier list. And this also goes by the name of the Pinwheel Galaxy. Very apt name for it. It's a spiral galaxy, obviously, and it's in the constellation Ursa Major, not far from the Big Dipper. Now, if I zoom in on it a little more, you'll see that there are numerous arms spiraling off of this particular galaxy. So, and if you look very closely at the center, there's almost a little bit of a bar there. I believe this particular galaxy is actually called a barred spiral because of the bar shape in the very center of it. The Pinwheel Galaxy is 27 million light years from Earth. So a little closer than the Needle Galaxy that we looked at earlier, which was 40 million light years. 27 million light years instead. And this is a face-on versus the Needle Galaxy. So what you could think of when you look at this galaxy is this is what the Needle Galaxy would look like, probably, if you could twist it 90 degrees so that you could see it face on instead of edge on. And vice versa, if you took the pinwheel and were able to twist it 90 degrees, it would probably look much like the Needle Galaxy does. So again, proof that galaxies are large plate-shaped objects in the sky. M101, or the pinwheel, has over 100 billion stars. And it's about 150,000 light years in diameter. So it's actually larger than the Milky Way galaxy. There's approximately 5 arms. If you look closely, you can count 1, 2, 3, 4. Let's see, I see 4, maybe 5. One very large one that's spiraling upwards, another really large one that's spiraling downwards and to the left, going kind of in the direction of that bright star on the far left side. Now you'll notice in those arms, there's what's called bright knots. They look like little bright knots. The lower arm has a very conspicuous one, and the upper arm has a fairly conspicuous one right at its tip as well. But you can see a bunch of them throughout the spiraling arms. Those bright knots are huge star-forming regions, areas within the arms of the galaxy where the gas is condensing down and forming many, many new stars. And because of that, the new stars tend to brighten up those areas and make them glow more brightly. These are also called H2 regions. They're called that because the gas clouds are predominantly hydrogen gas that are forming these new stars. And this particular galaxy has a fairly bright central core right in the middle of it. Like most galaxies, I'm sure it has a large black hole in the center as well. But of course, we can't see black holes, so no point in trying to show it to you. By the way, a lot of people ask, what are all these little points of light all speckled around and within the field of view? Those are stars in our galaxy. So remember, for us to see out to galaxies beyond our galaxy, we have to look through our galaxy first. So these are stars that are in the foreground. These are stars that are close by to us, like 10,000 light years, maybe 20,000 light years distant. And we have to look through those stars in our galaxy before we can look at something more distant. So those stars are foreground, and the galaxy that you're looking at is 20 million or 27 million light years further away. And in between, there are no visible objects. There is just the blackness of space between our galaxy and this galaxy. So if you took if you were in a rocket or a spaceship that was going to this galaxy, you'd pass all the stars of our galaxy, and then you'd be in the blackness of intergalactic space until you reach this next galaxy, which would probably take you millions and millions of years to reach. Any other observations, gentlemen?
Yeah, that's a really I always enjoy looking at that because it shows the spiral arms so well. So, you know, if you're if you get out to a dark site, and if you've ever viewed the band of the Milky Way going across the sky in the summer, in particular, the brighter band, and even the winter Milky Way, then that one is, you know, if you kind of envision us being out on about halfway out from the center, then the band, you know, in the summer, the band that's going across the sky would be kind of like the arm that's going in the next arm in on our galaxy. And same in the winter. In the winter time, the band is lighter, it's not as heavy, and that's because we're looking at the next arm going further up. All right. Rick, you're up.
Yeah. Now for something similar to Bernie, but different. I'm going to be looking at just a few galaxies. So this might just look like we're looking at a star field, but this is a bit of a Where's Waldo picture. What you're looking at in this picture, there are more than a dozen galaxies in this picture. Right along here towards the center is a whole bunch of them, and this was named Markarian's chain. He's the astronomer who discovered these. So there's some very bright, you can tell they're not stars. They've got some of that oblongness to them and a little bit fuzzy. Two down here are called the eyes galaxies. But start looking around this picture, and anything that's a little bit fuzzy looking is a galaxy. There's one down here. There's one over here. There's one up here. There's one up here. I think that's one. There's one down here. If I did a longer exposure, we'd get even more. This is an area of the sky up in the constellation Virgo. And this is an area of space where we're looking really outside of our galaxy, looking out into deeper space. And this area is just stuffed with galaxies in this area. These galaxies are all very distant. They're all in the 35 to 60 million light years away distance. In fact, Jim, I was going to say, if we had a little bit of time here, maybe you could bring this up in Stellarium and show in Stellarium how many galaxies are in this region here.
Yeah, and before I do that, while you've got your picture up here, if some of you may remember several years ago when they took the picture of the supermassive black hole in the center of M87, which is a huge elliptical galaxy. And that is part of this constellation group. I think in your picture, it's the one at the above center, the bright elliptical looking one right there. Yep, I think that's M87. And sometimes if you zoom in on that, you can actually see the jet of material coming out because it's got a very active supermassive black hole. But when they took the picture of M87, there's so much material than the supermassive black hole was really having a feeding frenzy. And so all that glow, because the material would really heat up as it would spin around this black hole. And that's how they were able to image the black hole. We can't really see the black hole. We can just see the material coming around the black hole.
And I've zoomed in here now, so now you can really see the chain. It's here, it's along here, a couple there, and it just goes on down here.
Yeah, they're everywhere. I mean, it's just
they're everywhere.
Just a picture full of galaxies. So in Stellarium, this is what it looks like here when you're zoomed in, the picture they have. And M87 is the one that's highlighted down here at the bottom, but you can see the chain of galaxies. And as we zoom out, you'll be able to see that it's just off in the constellation of Virgo. So this is Virgo right here. And so it's just off her right shoulder in between Virgo and Coma Veronesis.
And everything from her head down to her feet is just stuffed with galaxies.
Yeah, it's a very popular place to look for lots and lots of galaxies. All right, Jim, you ready? Hello, Jim. All right, how about Bernie? You ready?
I am.
So, sorry, I had the mute on, and when I ran over,
let Jim
when
go.
I ran over to do it, I happened to hit a cable, and it jiggled the scope. So now I'm waiting for it to settle down, but I do have an object ready.
Okay,
If I-
well, you can go ahead.
Oh, the screen actually
you-
settled down a bit.
All right.
So let me get it up there. And this seems to be galaxy night. This is the season for it. And let me try to share a screen, find an object. And here he is. Okay. That little gem there is called M82. It's Messier object number 82. It's a galaxy fairly close to us. It's got two names. It's lumped with M81 as Bode's nebulae in some references. Otherwise, it's called a cigar galaxy. It's a very wondrous kind of thing. It's a starburst. It's called a starburst galaxy. That means it's forming new stars at a prodigious rate inside that galaxy. In fact, it's 12 million light years away from us in the constellation Ursa Major, and recently spiral arms have been discovered. But actually, what you're seeing there, the glow that's in the middle, there are nearly 200 massive clusters of over 200,000 stars in each of the clusters, very large and bright. And in fact, on opposite sides of the slash you can see across it, the dark bar across it is actually dust that's been blown out by the creation of all these stars as they got created. Their outgassing actually got all the non-stellar material that is tied up near the core. And the reason that all that material is near the core, the dark material, is because there's two massive black holes in the center of that galaxy. It's kind of unusual to have that many supermassive black holes. That's that's an easy object to see in a smallish telescope. You don't need a whole lot of power on it because it's only 12 million light years away. But I kind of like that one because it's one that I can find very easily.
Yeah, and I like looking at, I'm in the telescope looking at both Bode's galaxy and the cigar galaxy in the same field because it gives you a good impression of a nice edge on and a nice face on view of two galaxies.
Well, Bode's galaxy, the one, the M81, is quite a bit bigger than this galaxy, but it's almost a face-on spiral. It's nice round. It's got a nice round shape, but it's also got because it's nearly the same distance away. It doesn't have as much surface brightness because it doesn't have the concentrated stars that this one does. So it's a little difficult to see detail in it unless you really get a bigger opening scope, a bigger aperture on M81. But M82 will give you a show down around the 8-inch to 10-inch scope. It'll do pretty good. It's got all that modeled effect from all those clusters.
Yeah. All right, we have about 20 minutes left, so maybe we'll go around the horn one more time with an object each, and then we'll call it a night. So we'll go back over to you, Bernie.
Okay. Am I still there?
I hear you.
Yeah, I got you. Yep.
Oh, okay. Sorry. All right, I'm going to share. This will be my last object unless we need to, unless we have extra time, but I don't believe we do. So this will be my last object. There it goes. All right. All right. What you're seeing right now is a number of things. So I'll do a little explanation first. Right in the center of the screen, that big fuzzball that you see is M60. M60 is a giant elliptical galaxy up in the constellation of Virgo. Elliptical galaxies are rather boring to look at because they don't have any discernible shape. They just have a central core and usually a big fuzzy area around them, which is the stars associated with it. Now, right above that large, brighter galaxy, you'll see another fuzzy patch. That is a smaller galaxy, another small elliptical galaxy by the name of NGC 4647. Now, what I really brought up this image to show was the dot, the bright dot just below the smaller galaxy that's in between M60 and that smaller galaxy. That looks like a star, much like the other stars that are around. That particular star, however, that bright spot there is actually a supernova. It's a star that just exploded into supernova on one of the spiraling arms of that smaller galaxy. And this just happened or was spotted on the 14th of April. So it's just newly discovered supernova that just occurred. Now, what's a supernova? It's an explosion of a very large star. And I might let Jim do more of an explanation on what a supernova is. But what I'd like to point out is that this is a type 1A supernova, and that is typically caused by infalling matter from an adjoining star. So it's usually a binary system. There's two stars. One's a white dwarf. The other one might be an ordinary star or a giant red giant star. And the white dwarf is drawing matter in from its secondary star. And when it sucks up just the right amount of matter, it explodes in what's called a type 1 supernova explosion. And as I pointed out, this is a relatively new one. It was just spotted on the 14th of April. I'll pass that on to the other fellows.
All right. Yeah, that's really cool to be able to see something like that. And you'll frequently hear people say, that the supernova, when it happens, outshines its host galaxy. And this is a perfect example of that. If you look at it, it is brighter than the galaxy that's hosting it. So it's very interesting to see something like that. And it'll be bright like that for, maybe a few weeks, and then it's going to start dimming out. And then eventually there'll be a remnant, and if you were in that galaxy, you'd be able to look at it a little bit better, but it would be a remnant of like what Jim showed early on of the M1 Crab Nebula, which is a supernova remnant. So you'd be able to see the gas coming out from that supernova. So supernovas typically have to be mostly fairly large stars. Now, in this case, the white dwarf is actually, as Bernie mentioned, is actually pulling the material from the larger star. And then it gets to a point that it basically hiccups or burps as it's eating, and it goes supernova by, kind of infalling, and it'll compress down on itself. And then the rebound effect will blow the material out. So, you can kind of think of a supernova as if you were to have a basketball and a tennis ball on top of the basketball, and you drop them both at the same time. When they hit the ground, the basketball rebounds really fast. And that's what's happening inside of a supernova, is the material compresses down so quickly that it hits the core, and then it rebounds back out, and all that material gets blown out. Now, frequently, the core of the star is still there. And so then it could become a neutron star or all kinds of different kinds of stars. But so it's kind of special to be able to see something like that in real time.
Yeah, and they don't happen all that frequently. I think if I remember right, it's said that within a given galaxy, there may be a supernova once every 100 years. So the only reason that we get to see them as frequently as we do, maybe a few a year, is that there are so many galaxies out there that the probability is that there'll be visible ones during the year somewhere in some galaxy that we can see, because there are thousands of galaxies that are observable in moderate to large amateur telescopes.
Yeah, and I don't remember how long it's been since we've had one in the Milky Way, but I think it's been quite a while.
400 years.
Okay, there you go. So
and it was the last visible one.
Yeah, we're due for one, aren't we?
That was seen by Kepler in around 1609, I think. 1609, I think. In 1680, Sir Isaac Newton found one when he was testing a Newtonian telescope in the Milky Way, but that had to be found by telescope. But the last visible one we could see from Earth was about 400 years, a little more than 400 years ago. They should happen every 50 years for a galaxy the size of the Milky Way, and cosmologists have been wondering for a long time why we're so overdue.
So that means we're getting some pent up stars out there, and they're just going to explode sometime.
There's always Betelgeuse.
We're going to get a whole bunch of them all of a sudden.
That's right. All right, let's roll over to Rick for your last one.
Yeah. I just had some interesting crackle in my yard. I think I got some javelinas up above.
They don't eat much.
Okay, so we've got some faint nebulosity here again, and the reason it's faint is this was taken looking into the glow of Tucson. You can see it's darker over here and it's a little lighter over here. Well, that's the Tucson city glow. So this is your advertisement for light pollution. Looking at here is called the main event here is the Flaming Star Nebula. If I was zoomed in more, the star becomes more apparent if I take a narrower image. But the driving star here has a interesting history. When they trace that star's proper motion back, it was originally in the area of Orion's belt, but about 2.5 million years ago, the star had a close encounter with the Orion Nebula. And the encounter that was so close that there was a couple stars that were ejected from the Orion area. And that's where this is now. So this is a ways off in the constellation Auriga. The complex itself is relatively close to us again. Well, it's further than Orion. It's about 12 and a half diameter. It's about 1,400 light years away. So it's about the same distance away as the Orion Nebula is. Okay, that's all for me.
That's kind of nice to be able to see so many nebulas in the
Oh yeah, there's
clouds.
a whole bunch of
yeah.
other ones here. If I was shooting it on the other side of the sky, right down the sky globe, there's tons of little nebulas. They're just unnamed. They just have numbers attached to them. There's ones all around this area.
Yeah, and I will just put in another plug. We're fortunate here in Tucson to have some pretty decent lighting ordinance, but anything you can do to reduce your lighting around your house is a good thing. You know, we tend to put most of our lights on motion, whether motion lights, so that they just come on when they need to. Otherwise, it's nice and dark. So it's a good opportunity to get your attention when they do come on. You get up and look, and 9 times out of 10, it's a javelina or a coyote or some other critter wandering through the yard. Okay, Jim, you got one more?
Sure do. Let me go try to share something here. And there, hit the other one. And I've got an old friend of ours up there that a lot of astronomers look at, as I assume it's coming through by now.
Yes.
I hope.
Looks good.
Okay, that thing is called a Whirlpool Galaxy. Now that the main galaxy itself was discovered by Messier and Charles Messier on October 13th, 1773. But so his catalog name for it is M51. That's the 51st object he found. Its scientific description is an interacting grand design spiral galaxy with an active galactic nucleus. The galaxy below it, to the lower right of it, is called New General Catalog number 5195. That wasn't discovered. That was discovered by Messier's partner, Pierre Méchain, about 8 years later after they discovered the big one. They're interacting. You can see a material flowing from the bigger galaxy, between the bigger galaxy and the little one. And the bigger galaxy, if you stare at it for a while, you can see it might look a little deformed, and that was because that little galaxy actually was zoomed by it and behind it, and it's quite a distance away from it right now. But that material that's kind of going over to it was pulled away by the gravity of the smaller galaxy when it pulled behind it, and it's in the constellation Canis Venatici. And if you're into mythology or into legends, those are the hunting dogs of the constellation Boötis under the handle of the Big Dipper. So that's where this is. It's right underneath the arc of the handle of the Big Dipper, about maybe a fist or so down below it. It was the very first galaxy to be classified as a spiral galaxy. It's about estimated at about 31 million light years in distance, and from us, and it's about 3/4 of the size of our Milky Way. So it's about 75 to 80,000 light years across, but it's only got 11% of the Milky Way's mass in there. So that's another one of those mysteries, is how did that thing form and where did the mass go? Why is it such a big shape when it doesn't have the mass? And the countering argument is it's got such a big shape because it doesn't have the mass of a lot of material holding it tighter. So it's a a lot of speculation. You can, if you want your chance for PhD, go figure out why Milky Way is 3/4 the size of, why M51, the whirlpool, is 3/4 the size of the Milky Way, yet it's only got 11% of the mass.
Yeah, that's another one that's always fun to look at in telescopes, and to be able to see the two galaxies, one large, one small, interacting with each other, and you can see the dust lane going between the two of them. So that's cool.
I always thought it looked like a video cassette, if anybody remembers VCRs.
Right. Exactly. All right. Thanks, Jim. That was awesome. So we're going to wrap it up here. I'm going to just put this up real quick so you can see what we got coming up again, and thank everybody for coming. We've had a great time. We always enjoy doing the virtual star parties because it's a chance to share what we've got here in Tucson, our good skies and our telescopes with people around the US and around the world. So we appreciate everybody coming. If you didn't get a chance to watch the entire program, you can watch it again later on our YouTube. It should be underneath the playlist for virtual star parties. You can also watch a lot of our previous ones there as well. Our next star party will be November 18th, so it'll be in the fall. We'll do one from 7 to 9 p.m. Tucson time. We'll be back in the mountain time zone by then, and so it'll be 2 hours off from the East Coast. So and yeah, be sure to let your friends and family know about this, and have them come check out our YouTube channel, and we put other kinds of interesting astronomy related topics on there, and some how-to kinds of stuff. We want to do more of that, things like that. So what I'm going to do real quick is I'll pass it around to each of the other astronomers, and they can say a few words, and then we'll wrap it up. So Bernie, you can start.
Well, I just wanted to thank everyone for coming tonight. I hope you enjoyed our star party. We try to give you a cross-section of different interesting objects that we look at in the night sky, and we just love sharing it with you. So thanks a lot, and we'll see you next time.
All right, Rick.
Yeah, it's been a pleasure, everyone. Something I always encourage everyone to do is go outside on their own, night sky. You'll be amazed if you own a pair of binoculars. Take them out and look up. You'll be amazed at what you can see just with a pair of binoculars. So, dark skies, everyone.
All right, and Jim.
Yeah, I'm going to join everybody else in saying thanks for showing up. I think we got a chance to prove how flexible we could be, because I had nothing but trouble with the tools I'm working with out here. But we got it to bring some adventure to you. And I would say that this has been one of the more complete nights of our virtual star parties. We got to look at a lot of different objects. The one problem we got is not many of the planets are up. They're all in the morning area, or mostly in daytime right now. But if you go out tomorrow night, somewhere around 4 o'clock or so in the morning, your local time, 4 to 5 o'clock, you'll see the visible planets except for Mercury. The other 4 will be in a straight line in the eastern horizon, pointing up to the sky. And if you wait a little later, a few weeks later, you'll get to see the moon right in the middle of them. So right now we're happy to be lucky that that's available for us to look at, but I don't get up at 4:30 in the morning for any reason, much less looking at planets. And thanks everybody for tuning in.
All right, everybody have a great evening, and we'll see you at the next one.